In this session, we're going to look at lessons 38, 39, and 40. In lesson 38, we're going to start with permutations. And the question that they ask is they give us four numbers, 3, 5, 7, and 8. And they ask how many different ways can they be arranged if no repetition is permitted. Well, if there's four numbers and we're arranging all, we can use all four of them. And we're going to create four boxes. And in these boxes, if you cannot repeat the numbers, which means once you use one, you only have three options next. So in the first box, we have four options. We can use any of the four numbers. But once we've used one of the four, we only have three options next. Once we've used one of the three, we only have two options next. When we use one of the two, we only have one options next. And so then what it ends up being is 4 times 3 times 2 times 1. 4 times 3, obviously you can put it in your calculator to make it really fast. 4 times 3, though, is 12. 12 times 2 is 24. 24 times 1 is 24. So the answer is there are 24 different possibilities for those four numbers. The next one of the same type is they give us the word equal. And they say how many four-letter signs can be built from the word equal if you can repeat. So you can have a four-letter sign. So if there's only a four-letter sign, now I know there are 5 letters up here, but the sign is only going to consist of 4 letters. So you can have a sign of all ease, because if you can repeat, you can have a sign of all ease. But they're looking at possibilities, permutations. So what you can do is there are 5 possibilities, but if you can repeat, it's 5 times 5 times 5 times 5. Then whenever you do that, you're going to get 625. This is the idea of permutations and possibilities. Last one of the same type, they give us the word numeral and they say 3-letter signs. So 3 boxes, and you cannot repeat this time. It's a 7-letter word, so 7, 6, 5. Multiply those together in order to get your answer. Whenever you do that, you get 210. That's permutations. On this next one, what they do is they give you the answer and they want you to work backward to the problem. Now the way they say it is they say write the quadratic equation with a lead coefficient of 1 whose roots are -3/5 and 1/2. A lot of times you read that, you see the word lead coefficient of 1, it freaks you out. And the only thing you got to realize is the lead coefficient of 1 simply means x and x have nothing on them. You're going to do the opposite signs of the roots or the answers, and you're going to set it equal to 0. But the lead coefficient of 1 just means those have 1s in front of them, which doesn't affect anything. When you multiply this out, you get x squared plus 3/5 x minus 1/2 x minus 3/10. You simply add these two and you have your answer. You have x squared. This is going to be 6/10 minus 5/10. So you get 1/10 positive x minus 3/10 equals 0. This is the answer, and this is, if you were to plug this into the quadratic formula in your calculator, it would give you these two answers. And that's a way that you can check to see if you have done these problems right. This next concept of lesson 38, or I guess the last concept of lesson 38, has to do with distance equals rate times time. And you can manipulate this equation. So distance equals rate times time. You could divide both sides by rate, and you could say time equals distance divided by rate. Or you could divide both sides by time, and you could say that rate equals distance divided by time. You can manipulate this however you want it to be able to make it what you want to make it. Now, whenever you look at this, they give us a problem that says Frank and Judy can drive for 100 miles at 50 miles per hour. Then they drive 180 miles at 60 miles per hour. What is Frank and Judy's overall average rate over the whole trip? So if we're looking for overall average rate, we're going to say overall rate equals overall distance divided by overall time. So we use this manipulation of the equation. And so you can put them in individually. If they drove 100 miles and then they drove 180 miles, it says how fast must they drive for the last 120 miles in order to have an overall average rate of 60 miles. So we already know our desired number is overall average rate of 60 miles per hour. Here's the distances. We actually could figure out the first two times because they gave us the rate of the first two distances. They did not give us the rate here, so we can't figure out this third time. So time 3 is what we're going to be figuring out. Now, they said that they drove 100 miles at 50 miles per hour. Divide that out. Well, that took them 2 hours to do that. So our first time is 2 hours. Now, when they drove 180 miles, they did it at 60 miles per hour. Divide that out. That's going to be 3. It took them 3 hours. So all we got to do is find the missing piece of this puzzle. Add everything on top, and everything on the bottom ends up being 5t3. Add it on top, that's 300, 400 miles. Multiply both sides times 5 plus t3. That cancels. You get 400. You get 300 plus 60t3. Subtract 60t3 is 100. Divide by 60. You find out that time number 3 is going to be 5/3 hours, or an hour and 2/3 time. Now, that's not what they wanted to know. What they wanted to know was what was the speed on the third leg. Well, if it was 5/3 hours, you would take, in order to find the rate, you would take the 120 distance of the third, this was leg 3, the 1/3 distance, divide it by 5/3. You flip it, bring it to the top, and it ends up looking like this mathematically. The 5 will cancel here. That is 24. 24 times 3 is 72 miles per hour. So 72 miles per hour was the rate for the third leg of the journey. The next problem has to do with changing things from radians to degrees or degrees to radians. Anytime you see pi over 4, pi over 3 in a trig problem, what you have to realize is those are in radians, and they have to be translated to degrees by using the unit multiplier of pi over 180 or 180 over pi. Obviously right here, we need it to be 180 over pi. When you do that, you multiply everything out, and then you get 180 divided by 4, which is 45. So this really looks more like sine 45 degrees plus sine 180 over pi divided by 3 is sine of negative 60. So now you put in your calculator 4, or just do sine 45 first. 0.7 over 7, which we know is root 2 over 2. Multiply that times 4, plus the sine of negative 60 is negative root 3 over 2. So this will be 4, it'll cancel, so you get 2 root 2 minus root 3 over 2, and there is your answer. The next concept is from lesson 39, and it's called Forms of Linear Equations. You need to look at your book at the part that I have squared or I have put in a box, and you see general form, slope-intercept form, double-intercept form, point-slope form, two-point form. You need to put those 5 formulas on your formula page. You may want to pause this and write this down, or go in your book and write this down. But all you're going to do in this is you're going to take a normal linear equation and manipulate it to where you put it in those forms. I'll give you one example, and then we'll just look at other examples in class to where you get this. But all it is learning to manipulate linear equations. So in this one, you see they give us y equals negative 7/3 x plus 1/5. That is slope-intercept form. That is normal linear form, what you are used to. Here is general form. So you can manipulate this equation into this equation. So you can see that everything needs to be on one side and set equal to 0. So let's bring everything to one side. We're going to get 7/3 x positive plus y plus 1/5 equals 0. The last step in this problem is we're going to multiply everything times 15. Still get 0 on this side. The point is that we have all whole numbers. So we eliminated the denominator. We get 35x plus 15y plus 3 equals 0. So that's how you take something from linear form to general form, just manipulating equations. Our next problem is logarithms. And if you see, we have like logs, log A is the base. And that's what I mean by like logs. When the base is the same, then you can end up dropping the bases here in a minute. What you're going to do is when you see log A4 plus log A6 equals that, plus means multiplication of the logs up there. So it'll be 4 times 6 equals x plus 4. We drop the logs, multiply here, so you have 24 equals x plus 4. So 20 equals x. That's what you do when you have an addition. Here's 3 more quick types of logarithms. On this one, you'll notice it is subtraction. Because it is subtraction, we're going to divide x plus 6 divided by x minus 1 equals 5. They all have log 4 as the base, so we can drop the log 4, multiply both sides, times x minus 1. You get x plus 6 equals 5x minus 5. Bring the x over here, you get 4x equals 11. The answer to this problem is 11/4. The next one, whenever you have a number in front, you're going to bring this and put it above the x. So it becomes x cubed equals 8. We can drop the like logs. We drop the log b. Take the cubed root of each side. When you do that, x equals 2. Last one right here, same thing. X equals 64 to the 2/3 power. You put that into your calculator, and you will find that x is 16. The last problem, or the last concept, is on lesson 40, and it's properties of inverse functions. And the question is, are these two functions inverses of each other? The way you figure that out is you take one and plug it in the other, take the other and plug it into the one. So if you have 1/3 parentheses, and you put 3x plus 9 in here, then you have 3 parentheses, 1/3 x minus 3 plus 9. Then you work them out. If they're equal, if the answers are equal, then they are inverse functions. So right here, when you divide 3 by both of those, you get x plus 3 minus 3, and you get x as your answer. Over here, when you multiply 3 times these, you get x. Wow, almost messed it up. X minus 9 plus 9. Then you're left with x. The answer is yes, they're inverse functions. That is it for lessons 38, 39, and 40.